G'day YouTube, it's Turbo Tristan here. Welcome back to the channel. Today we're going to be doing something that we talked about a few months ago and I'm sure everybody wants to know the answer to, and that is eBay coilovers versus everything else on the market. We want to see if they're any good, are the rumours true, and we're going to test them out now. We're down at SHOCKWORKS in Melbourne, Victoria, and we're going to use their sophisticated dyno. We're going to learn how it all works because I have no idea. And what we're going to do is we're going to test the famous Maxpeedingrods eBay coilovers. These ones are the 24-way adjustable, height adjustable coilovers that a lot of people run. We've also got another Maxpeedingrods coilover. This one is even more budget than the already budget eBay coilover. We don't have the anodized fittings on this one, so we're going to test that and see if it's any good. We're throwing those two up against the ever popular BC coilover. These are the BC Reds. We've also got a CUSCO height adjustable coilover, damper adjustable. We've also got a pretty fancy looking AMR engineering coilover. This one's assembled in the USA, so we're going to compare that against the Chinese and Japanese ones. And I've also brought the Germans along with a BILSTEIN rear shock. This one is out of an Evo. Sorry I didn't have a Civic one, but we're going to check this one against the Civic stuff just for fun. And as well as all of those, we have the control. And now in every test there's always a control, and this is the benchmark, the base, so to speak, the starting platform. And this is a 30-year-old OEM factory Honda shock. We're going to test the shock against the aftermarket coilovers to see if this even compares with some of the aftermarket coilovers that are available. And it wouldn't be right to come all the way out to SHOCKWORKS and not dyno one of their shocks. So this is a SHOCKWORKS shock for a Civic as well. So only fair, we test them all. So stick around, this is going to get interesting. So welcome back to the channel. We are down at SHOCKWORKS. This is Chris.
Hey guys.
We're in his top secret lab where he makes lots and lots of top shelf quality custom coilovers for all makes and models, but he's kindly reached out and let us borrow his state-of-the-art dyno here, and we're going to get all the information on a graph on the screen here to take a look at once we compare them all. So this one's the OEM. I can't see.
Would it be KYB usually, or is it SHOWA? Yeah, SHOWA.
SHOWA,
well. Yeah.
Okay, SHOWA brand. Yeah. Then we have the AMR engineering ones. The CUSCO, now these say made in Japan there. We're expecting some quality out of that. And then we've got BC. Most people, you know, they have a decent opinion of these. Very popular for people who just want to go low. The Maxpeedingrods ones down here, these are the budget ones. Some people love them, some people hate them. And you always hear lots of things on internet forums about them. We've got two different kinds. This is the one that most people go for. Brand new, they're about 350 bucks delivered. And then we've got these ones here, which they're telling me are going to be even cheaper. For those of you that don't know, I'll just get Chris to be the hand model and point to some of the things on a coilover so we know what every part's called, because he does this every day.
Sure. So we've got this is the locking ring. So you'll notice these are like a CNC cut, where you'll see with something like this is a more of a cast sort of look, where they've had to just finish it with machining. So this actually, for the most part, would be a cheaper manufacturing process than these. Outside of that, we have a top mount. So these 1, 2, 3, 4 are like a CNC cut, and then this is, I don't know what material, but this even has a spherical bearing, mate. That's fucking beautiful stuff there. I have no idea what material it is under here. I would assume it would be steel, probably like a cast steel. And then with the factory, they have the ability in such a mass production to press steel everything. So the top mount here, everything's one piece that's then pressed and formed and heated. All the little brackets are pressed rather than machined, because they're making several thousand of them at a time.
Hundreds and hundreds of thousands of Honda Civics out there. They would have made those babies cheap.
Oh yeah. Back in the day, maybe a $15, $20 damper, something like that. Wow. I honestly have no idea how they're able to make that. I don't know. If these are half good, these are pretty good for 350 bucks, because There's no way I could make to make a single corner for that much money is a mad feat. So yeah, let's see what they do. This is our Dynamic Suspensions Multimatic dyno. So this measures shocks up to 2 meters a second. This is our load cell here. This measures up to, I think, 1.2 ton. We have maxed it out a few times, so you definitely have to watch the trigger here and cut it off because it can get a bit dicey. So it measures up to 2 meters at a 75 mil stroke. So as far as cycles goes, it's pretty nuts. It turns the damper into a blur. We're not going to run the shocks that hot today. We'll only measure them to 1.2 meters a second, but then get a base from there. From here we have the computer and the software that we use. So we might just go over sort of some of the baselines of what we're looking out for. Okay, so this top line here we have the rebound force. Bottom line is compression. So you'll see at the bottom we have peak velocity, millimeters per second. And then, so left to right we have speed, and then top to bottom we have force. So this is measured in kilos. You'll see on the left hand side here we have 200 kilos. So this shock is making roughly 200 kilos at 0.6 meters per second. The shock will measure 3 cycles at every force and then go to the next speed from there.
This graph that we're looking at now, for those guys at home just like me that don't really understand it too much, what would this graph be from, and would this be a pass or a fail or a high quality or a low quality graph?
This is a sign of a digressive shock. So by digressive, the force is digressing. It's not building in a linear fashion, where if I pull this one up, so if we pull this up, we'll see this is a linear shock. So this is building force in a straight line going up. So body control of a shock happens between 0.2 and half a meter a second, depending on where it's mounted and what the car is and what speed you are doing. But for the most part, this is the force. So to get body control with this, you need to have top end force because it's being built in a linear way. Where by having a digressive shock, you can see we can have the body control here, but then up the top, we have the force digress.
What usually happens when you go over a bump?
So a pothole would happen at almost, well, some depending on the speed, up to 2 meters a second. So a real hard bang, we're going well off the chart of what this measures to, 2 meters a second and above. So going from here, this is the generic sort of graph that you'll see if you're buying shocks from someone. This is the graph they will show you. This is called force velocity. This graph is force displacement. The rebound force here, and then the compression force here, and these lines are the speeds going up through the point as it's going up from here. So this is the lower speed and this is going into high. And you'll see with this damper, this is a good shock because it's making a certain amount of initial force and then building up to it. And you'll see it's completely symmetrical as it's going from in, as it's going to out. It's almost perfectly symmetrical in its stack. To give you an idea of what an average shock will look like. See, this is a lot rounder. You'll see everything's taking. So this is over a 70 millimeter stroke. So this point is a 35 mil stroke to this half, and then we have 35 mil going out of it. And you'll see as it's going into the higher speed, this is actually showing lag here. So the force is dropping away. Nice patterns and everything's looking nice is what ideally we want to see. This is what a very laggy damper looks like. So we'll see that it's almost it's taking some 50 millimeter of rod travel before it's really making 50 kilos of force at 50 mil of rod travel. And that's at 1 meter a second. So that's a pretty fast input as well. So this is the extreme. I would hope that none of the dampers we measure up look like this. So one thing that I've learned today is when you test a shock on a shock dyno, you always put it onto the softest setting. So before each of these tests, this is on the softest setting where it's applicable. If it doesn't have any adjustment, we just don't touch it. But if it has adjustment, we always go to the softest setting. This BC has soft and hard already on there, so nice and easy. The other ones, we got to kind of work it out ourselves. So Chris is just calibrating the dyno now. He's zeroing everything off, so it's a fair and brand new even playing field. It's like, is that like when you zero some scales, you sort of step on and step off and then it goes back to zero? Yep, pretty much, yeah. So just depending on the weight of the object that you're hanging off it, it can kind of change how things read. So this just kind of makes sure everything's set back to standard.
So we're going to be doing the rear shocks. These are all Honda Civic shocks except for the BILSTEIN. That's actually out of an Evo. And to be fair, these ones are new. All of the other ones are second hand. This one's about 20 years old. This one's about 10 years old. This one's about 30 years old. That's the factory one. And the CUSCO and the BC. Now this one, although it's chewed out, very good friend of mine gave me these, and he said that they've only had about 4 months of use, but the person who he bought them off didn't have the spanner. So that looks trash, but apparently it's pretty new.
I think it's also worth noting, even after a large amount of kilometers, unless the shock has been, unless the valve has been built up with the wrong forces, it shouldn't, unless it's dropped gas, it shouldn't really drop more than 10 to 15% of overall force. So while we might see a little bit more increased lag in the older shocks, the overall force shouldn't be affected overly. So I think even if they are a little bit older, it's relatively level.
So a 30-year-old shock that's not leaking any oil anywhere should be within about 15% of what it was brand new?
Yeah.
Wow, okay. Learn something new every day.
So this is like a spring disc. This is what actually this is the valve inside the damper, and we'll see it spring. So while it's having to stretch over maybe potentially billions of cycles, unless the disc has failed, it's still going to present an even amount of force, because it's never exceeding, the way the piston is built, it should never exceed a certain amount of force. And you'll see up in this corner here as it does its little plot. So it's got 15 kilos of end load. So this shock is a little bit down, as we spoke about before. The valve can still last a long time, but this gas pressure should be a little bit higher than this. So this may have already leaked a little bit of gas out here. We're going to measure to 1.5 meters a second. I think that's good. So we're going to start out really, really slow, and that'll give a good resolution through its sweep. So this whole process takes about 50 seconds, so we might have to cut this one down a little bit, but you'll get an idea.
Yep.
So what we're going to listen for after about 0.5 meter a second is some of these are going to cavitate. You're going to hear that very noticeably. You'll hear air passing through oil noise, and there's got to be one of the shocks here today that cavitate. This might just over 1 meter a second, but for the most part, the BILSTEINs are usually reasonably quiet.
This is some ASMR shock noises for everyone at home. Can always put some little music or something over this.
Yeah. Just kind of good. It's quiet. That was a passing one. No real noise, no cavitation. I think it just cavitated a touch, but for the most part that was pretty good, as you'd expect from a quality BILSTEIN. See, look at this beautiful graph. That's a beautiful graph. Look at this. So we have force going up immediately. So this is, each of these blocks is 10 millimeters. So almost instantaneously in the high speed, you're going to see this, and then it builds the last 80%. Comparing that to, we don't have that there.
It's all right, we can compare it against the other one. So we've got the blue for BILSTEIN.
Blue for BILSTEIN, and this overall looks great, and this has got to be digressive, as it is. So perfect on the back of an Evo that has leverage like the Civics. This is the kind of graph you'd want to see. This might have a little bit of pickup in the low speed here, where it's going to pick up a little bit of ride texture, but with that trade-off means you're going to have great body control.
Beautiful.
All right,
on to the next one.
Beautiful. It's a little bit low on gas. I thought it felt low on gas. This may potentially lag a little bit. We'll see. Yeah, hear that? You just put your ear right up to it. You hear a tiny bit of cavitation. This has almost certainly dropped its gas. This should have an end load of about 250 newtons, and this is down to 45. So, yeah, you can hear that. Oh yeah. Could also be the sound of a sharp piston surface, but we'll be able to bend. Hear that? Not as bad as I thought it would be. So, given that there was more of a sheathing noise than it was cavitation, if I can show you a piston for a second, I'll go into my magic drawer.
We're learning here, people.
By hearing that sound at the very low speed, what that can be a sign of is a piston that has sharp edges. So instead of it having cavitation due to lack of gas and they're creating more and more foam, being that there was more of a noise at low speed than it was at high, what that points to me is that it'll have a piston with very sharp edges, which will actually shear the oxygen content. So this is a cheaper sort of aftermarket suspension piston. So you see with this, it's got very, very sharp, distinct edges. So this is going to create noise. A more premium sort of piston, you'll see all of the edges are tapered and round, therefore it'll make less noise. So just generally
slips through the oil a bit better.
Exactly. All right, so this is doing things. Now the most important one is the force displacement. So so that's showing as much as it's dropped gas pressure a little bit. Even though it's a lot laggy, you can see that this edge is a lot rounder. It's still symmetrical going in and going out of itself. So even though this doesn't compare, if we just quickly switch back to what the BILSTEIN looks like, see the edges are a lot sharper on the BILSTEIN here. So even though it isn't quite showing the same response of the BILSTEIN, it's showing that for the most part it's giving the force that it was from factory, which is, you know, pretty impressive for a shop that's done Ks.
Yep, so that passed the test, you'd say?
It's not a premium shock. I wouldn't be paying $3,000 for it, but if it was, you know, as a BC sort of battler, I think it would do pretty well. Time to measure up a standard Civic shock and see what it can do. It's SHOWA, and SHOWA's a quality Japanese brand. I've seen SHOWA in many a motorbike and many a car, so they've definitely stood the test of time. I'm not too sure if they're still around anymore, but
don't know what Honda use now for an OEM.
SHOWA.
If anyone knows, let us know in the comments what Honda use these days.
Still perfectly dry after all these years. Look, nothing on it. You'll even see with some aftermarket dampers, even after doing, you know, 1,000 Ks, you wipe it down and they still just leave the tiniest little witness mark of oil there. So once the oil starts going, that's when you're going to notice the performance drop.
So this is tight.
30-year-old rubber, still holding up.
Yeah.
Nice and quiet as well. It should cavitate if the world is fair and just, but we'll see. Begins. Not bad.
Not bad, okay.
There you go.
30 years old.
So you'll see, at half a metre a second, it's making 80 kilos of force. Now we compare this to a CUSCO, and you'll see this is making 200 kilos of force. So this is where, even though, now let's assume here, the hydraulic performance is comparable to the CUSCO. So the response, you'll see it's quite round. There's a little bit of lag in the top end, but this is a 30-year-old damper. This overall is pretty good. And now let's quickly swap back to the CUSCO. Overall, it's almost the same level of response. So the only difference in performance between this and the CUSCO is how much overall damping force there is.
So the CUSCO has greater overall damping.
Greater overall force, but the response between the two are very, very similar.
Very comparable. Fitting up the AMR, so that's the rear one of these. This is the made in USA, so for all my American viewers, this is the pride of the nation. Little squeaky.
Yeah, don't think the seal quality on this one might be as good as the SHOWA. It's not good. That's fucking random.
Okay, so this is the AMR, and even I can tell that there's something funny going on.
So maybe this isn't performing like the new version of it should, but given the force overall, I don't think this is really, this is the response on the rebound side. This is just generally strange. This is something, I've never seen something this weird before. But the rebound force overall, it's not any more impressive than, oh, that's actually pretty funny. The response curve, the roundness of it, is not really any more impressive than that of the factory damper. So as far as this having better response or performing better, while it does make more overall force than even the CUSCO by a margin, it's not that discernible.
Wow. Okay. So would you say there's something probably wrong with this one?
So the rebound force, this is probably going to be what it's making, but yeah, there's something wrong with the valve stack itself. The fact it was actually making a knocking noise, something has come loose in this.
So just to reiterate that, there is some kind of a problem with the AMR shock. Maybe, was it a valve?
Yeah, potentially a valve issue there.
Probably a valve issue, we don't know, without opening it up. But a good point is, for a premium brand, that should still last you 100,000 kilometers, no worries, and years and years and years without performing like that. So,
how many kilometers is on the EG damper?
Oh, the EG. So the factory OE one that we measured just before it, and you're probably going to see this in a different order, but this car had 350,000 Ks on this one. And it performed really, really well. So we'll give a recap at the end, but yeah, I just wanted to summarize. I don't want anyone getting upset, but these ones is a little bit of an issue, so they'll probably need addressing.
There we go.
Definitely hear some slushy noise now. That's got to be pushing out.
That's gone. That's lag forever. Yep, so laying this against the CUSCO as a baseline. So it's not making any of the low speed force here, but then it's accelerating rapidly in the high speed. So this is going to give you all the beautiful force to give you no body control with all of the high speed to then kick you in the pants when you hit a pothole.
So nothing then a big bounce. Oh wow, what does this mean? So it looks funny. Okay. What does it mean?
So in the high speed, even though we see on this graph that it's making 800 kilograms of force at almost 1.4 meters a second, in reality it's taking 15-20 mil to get there. Which means from a body control point, you're going to have this initial fall through, and then it's going to catch on the massive amount of high speed. That's where you get that real jiggle in your guts, because you have that fall through where there's no damping, and then it's really stiff.
Okay.
So this lag here, this is where you're really going to get that good bounce, where a normal, like a base damper. So this is going to give you control immediately. So you have this, where by not having that damping force in these points here,
the hand signals are really helping the simple guys like me.
That works, yeah.
Yeah, that's
so by having this roundness here, it means you've got a much quicker acceleration, and then it catches itself. You know when you have an elevator and you go to the ground floor and you have that little drop? That's exactly what this feels like.
We're going to test out their new design now. So these, I'm told, are a twin tube. It's a little bit of a different design. You can see here the rod is a lot thicker, and the shape down here, again, I don't know what I'm talking about, but the shape down here is different, and you've got a thicker rod. This one's actually got a pillow ball in the top of it, whereas this one is rubber. So we'll switch them over.
Done. All right, this time for sure. This is happening. We're doing it. There we go. Look at that. Beautiful. Like a ball. So just straight away you can hear this is a lot more silent than the other one. So whatever they're doing with this one, they should be doing with the other one.
Okay.
Look, we got end load. It's got gas pressure. There we go.
That wasn't a good noise.
Yeah.
Alright, so we've just measured the budget max speeding rods, and my theory is it's actually going to be better than the other one.
And it already looks nicer, more
So
of a lemon shape.
it's definitely more symmetrical, whereas you can see with the other one it kind of waves back and forward. See this is severe lag in the top end.
Yep.
Where the newer one, this is the budget one. Even though there is lag there, it's at least symmetrical going in and going out. So now let's compare the overall force. Okay, so normally we have something like the CUSCO, where this is a linear damper. The force is building quite linear. You'll see the compression force of it. I've got too many overlays here, but you'll see the compression force. It's almost digressive, but for the most part it's linear. Now we'll see with the max speeding rod, this is progressive. So we have almost no force, and the ramp rate actually accelerates as we get faster and faster. 80 kilos of force at the corner at the roll control, but then it has almost 600 kilos of force at impact.
So being that we're at SHOCKWORKS and they specialise in shocks and coilover kits, we managed to get Chris to pull one of his out of a box just for comparison. This video is all in the name of science. We want to get as many different tests done and out of the road as we can. So that way this video helps everyone out, and we've got as broad a comparison on everything that's on the market as possible. So we're very, very lucky. Not only do we get to use the dyno, but he's also helping us out with an extra shock to test. And this one is from a Civic. So we're going to see what it compares like compared to these guys.
This is what the SHOCKWORKS looks like. So you'll see it's symmetrical going into itself, the rebound, as it is going out of itself. The compression force here, as you're stepping up in the speeds. Everything is symmetrical. There's no lag as we're getting into the higher speed in either the compression or the rebound. And we'll see that to make peak force, it's making 80% of peak force within about 1 or 2 millimeters at a meter a second.
So 1 or 2 millimeters of shock travel is giving you its 80% of its max.
So comparing this to the Civic, you'll see everything is very round here.
Yep.
So even though there's no lag, so this is probably the best of the bunch. It's all very round. Comparing this to where everything, you'll notice the entries and exits are a lot squarer. So the force is ramping up a lot quicker, and that's where you get the body control from.
Yep.
And then from a force point, you'll see we have a peak, a ramp up of force into the body control, and then it digresses away in the top end. And if we compare this to the base CUSCO, you'll see that we have the same amount of mid-speed almost as the CUSCO here, but then more initial compression force to keep the weight squarer.
Yep.
But then it digresses in the top end. So it means if you hit that pothole, it's actually blowing away.
And that's why Chris is the expert. and that's why we trust him to do these dynos. Again, we're not being biased, we're just testing what we've got. It's all on the same platform, so it's just interesting. I didn't know before we came here, so now you guys know as well. Okay, so just taking a look over the SHOCKWORKS one. I'm really liking this Nardo grey or gunmetal grey colour of the anodizing. I've never seen that on a shock before. And the gunmetal spring. And you can just tell that the guys have put a lot of time into designing this. Everything is coated, and you know, I'm no expert, but you can tell just by looking at that that is some quality gear. And I was told these ones are only a couple of months old. They just look a bit scratched up, so ignore that.
Alright, let's cut these and the grand reveal of the BC. Wow! Okay, so it's very linear.
Extremely linear.
It's
got a big bubble up there.
It's got just, but it's what you'd expect for a linear damper. So this is definitely one of the, I think this is the BC V1, so this is their more entry level one.
Yep.
But so comparing that against the CUSCO again, you'll see the curve, the actual edge, the leading edge, it's very, very similar. This is a little bit more linear. So I think we have some conclusions. I think outside of my shock, I think the CUSCO pretty much wins.
CUSCO wins.
It's 20 years old. Even though technology's improved in 20 years, and I'm sure they have a more premium product now, it holds up against the some of the newer, more flashier models. So red is CUSCO, blue is BC. So we have similar mid-speed to the BC, almost identical compression force, but then in the top end, it's got 700 kilos of rebound force. So this is really, really going to start sucking itself in. The SHOCKWORKS there coming in. See, we have more body control overall than the others, but then it's more digressive. We have the budget Maxpeeding. That changes the graph a little bit. You see that it has a lower amount of compression force, but then it gets progressive and ramps up as you get over a meter a second. So it's, for the most part, I think just running out of room in the piston. So the piston is hydraulically choking. We're starting to get complex here now, but we have, let me cut a couple of the top ones now.
So the pink one?
The pink one is the normal Maxpeedingrod. Again, you'll see it's a very, very similar force to their budget version, just more of it overall. And then the AMR, which, while having a decent amount of body control, has some issues measuring up. So overall, I think the CUSCO is the best and the Maxpeeding is the worst. So you'll see the CUSCO compared to the Maxpeedingrod has almost double the force. We have 120 kilos versus 50 kilos. Yet once we get over a meter a second, the Maxpeedingrod runs out of room and it just increases force astronomically. It depends on your standard of what you want. If you're happy to live with a car that's a little bit bouncy and you're not racing the thing, then your standard really just comes up to what your application is. And if you have $300 to spend on coilovers, then they're not gonna blow up in your car. They're not gonna blow up on your car. Like they might serve the purpose. They will do what you think they will do. They are a $300, and for $300, they have some damping, so they are a damper. Now this is where something like the CUSCO show that you might be able to pick up a set of these for $400 on the second-hand market. They haven't leaked yet. You might get a good year or two out of them. Or I mean, these have lasted 20 years, so you might get a fair bit of use out of something like this. So in my opinion, if they're available, buying a second-hand shock is going to end up being more worthwhile for performance than buying a newer, cheaper variant.
Well, there you go, everyone. Hopefully that answers a lot of questions, and you should know by now, I'm no expert on these things, which is why we came and saw Chris at SHOCKWORKS. But hopefully that gives the internet a break from arguing and fighting and killing each other over who's got what coilovers and what's the best and what's the worst and who's an idiot for buying this or that. We've tested them all. We've tested the eBays, we've tested the BCs, we've tested CUSCO, AMR, the factory ones, which surprised the absolute hell out of me. The stock 30-year-old shocks, they seem to do amazingly. We did have a winner if you take the SHOCKWORKS one out, because kind of not fair. But the winner was the CUSCO. So it performed the best. If anyone has any comments or anything they want to say or argue about, let's talk about it below in the comments. But anyway, thanks for watching. Thanks so much to Chris from SHOCKWORKS. I really appreciate the use of his dyno. Everyone that reached out when I made the post on the Honda forums about who's got some shocks they want to lend me, straight away everyone was really generous and keen and happy to help, which is one thing I love about the Civic community or Hondas in general. All of this stuff was on loan. I'm not a millionaire, so I couldn't go and buy brand new ones of everything. So yes, some of them are used, but as Chris mentioned, they shouldn't drop that much pressure as long as you can't see oil and stuff leaking. They should perform similar to what they did the day they were brand new, provided there's no physical damage or visible signs of anything. So still a fair test, believe it or not, even though some of those looked a bit worse for wear. So thanks everyone who lended a hand and lent me their shocks. Guess what? You can have them back now. I'll be dropping them off in the next couple of days after I put them all back together. So thanks very much. Thanks for watching. Don't forget to like and subscribe. Spool up, and we'll see you in the next video.
I don't think I've ever used the dyno this much since owning it. It's finally paid for itself.
Yeah, it's helped a lot of people out, solved a lot of internet battles.
Well, I think it's worth reaching out. If anyone wants to get some shocks to us, get them out to us and I'll measure them.
There you go.
It only takes a couple of minutes to get it in the machine. So if you're curious about a set and you're putting it in the car, it's only 10 minutes work. So
if you want to learn more about SHOCKWORKS, I'll leave a link in the description for Chris's website if you want to reach out to him. If you've got a race car, whatever type of racing, drop him an email. You can see he's a good bloke. He'll happily help you out. If you do want to buy some Maxpeedingrod coilovers though, there will be a link in the description for that as well. And you can use my discount code, Tristan1, and get yourself 15% off.
So this shock was given to us by a customer whose car was written off, and we have done nothing with it for 5 years. So I guess we'll see what happens. So if anyone needs one corner for their FG, it's theirs for 20 bucks, alright?
20 bucks, you heard it here, folks.
This is a little bit low on gas, so it might lag a little bit, but overall it should still be 60 to 70% of that one, I reckon.
That's just the ring that goes under the springs bouncing around.
It's got itself a hula hoop.
Spot on.
Spot on. Still brand new.
After 5 years and a crash,
yeah,
that's what it's supposed to look like, folks.
Comparing that, look at that.
So which one's the new one?
The new one's the blue one.
The blue one, and the black one is the crashed old one.
Oh no, sorry. The black one is the new one. You can tell because the bleed's a little bit later. There
okay, so the black one is the new one, and the blue one is the old one from the crashed car.
And it's still almost perfectly symmetrical.
Almost perfect.
Go.